Okay, so today we're going to start talking about local issues. So glaciers, wind, water, everything that affects our little state of Illinois right here. So you can see here, this is the picture of the Principal Aquifer and Water Quality Summary from a different report. But we talked about this being the edge of the last glacial maximum and that a lot of issues that are in these areas all match up. And I kind of mentioned a little bit about this part of Wisconsin called the driftless, and we'll talk about why that exists. And then we'll talk about this geology. We call this geomorphology, is the study of the landscape around us. Why does it look the way it does? Where there are hills. I'm going to talk a lot about that. I'm going to talk about local issues. So following up with what we talked about with Chicago water and the Great Lakes, we're going to talk about Great Lakes formation, and we're going to talk last couple weeks on that. So one of the issues that I hadn't talked about before that I needed to talk about with water quality is radium. So when people come to Illinois to come to NIU, they're always like, oh, the water in DeKalb is toxic. Well, we already talked about iron in the water, and we'll talk a little bit more about that with this lecture series. One of the other things that we can talk about when people say our water was toxic is the radium that was in our water. Radium is a radiogenic isotope. So it's part of the uranium decay series. So remember we talked about uranium and uranium-238. Should all come back to you. Well, the bedrock around this area has some uranium in it that decayed with time. So as radioactivity decays, uranium becomes thorium, and then it goes through a whole series of things, and eventually it becomes radium. This is also related to the radon we have in our basement. So if your family has ever moved or we have a radon system inside of your basement, well, it's because of the uranium that's in our bedrock around here. As that uranium has decayed over, this has got a 10 to the 9, this has got 24 days, so many minutes, 10 to the 5th years, and then it's here to 10 to the 4 years. And then it becomes to radium, which only lasts 1,622 years. And then it becomes radon. And once that radium becomes radon, it becomes a gas. And that gas comes up into our basements, and it can last for up to 4 days, basically inside of our basements. When radon decays, it becomes polonium, which lasts for a few minutes. And then this is very, very short-lived in minutes, and then it becomes lead. Lead 206. So the radium in your basements is coming because of this problem. So we have radium in our drinking water supply because of this radon. Radium is a radiogenic isotope. It has two isotopes. It's what's called an alpha emitter. An alpha emitter can be stopped with a piece of paper. So it's radioactivity that really doesn't go very far. However, part of the problem with radium, because radium, if you put it in a glass, you're protected from the radioactivity. It's when you drink it. Because if I look at a periodic table of elements, so hold on, I'm going to pause. So when we look at radium in the periodic table of elements, it's down over here. It's in the same column as calcium. And what happens when we take calcium into our bodies? It becomes part of our bones. So what this does is, even though this is further down the periodic table of elements, so it's a little bit larger, it's still chemically things that are in this column here all react the same. And so radium can be incorporated into the actual bone structure of our bodies. So when that happens, with the radium inside of it, it gets inside of our bones, and since it's an alpha emitter, it just releases radioactivity just to the area right around it, and it can cause cancer that way because it's now inside of our bodies, it's in our bones, it's being released, that little bit of radioactivity is being released. If we get it into there, it has a half-life of 1,622 years, so it'll stay inside of our bodies once it's inside of there, giving off a little bit of radioactivity. So we have to remove it from our water because there is a maximum contaminant level. And so the maximum contaminant level is what's called 5 picocuries per liter. What's a picocurie? Well, picocurie is a measure of how radioactive something is. Okay. You can go into REMS, and if you watched, I guess I could look up, I'm not going to, the Rudgrins, if you watch the Chernobyl movie, it's not good, it's not bad, yeah. But this is actually very low radioactivity. I mean, and concentration of it is very low, is 5. The amount that it was in DeKalb is about 7 picocuries per liter. So there are 2 ways we can do that, get rid of it. One is the solution to pollution is dilution, so we could dilute it. So we'll talk about the upper aquifer and the lower aquifers that have radium into it and all that. We could dilute it, so we can dilute it down to 5. Or what we can do is use a water softener. So we have an ion exchange. So if you look at the water tower that's over by the Convocation Center, there's a little gray building next to it, and inside of that building is a ion exchange facility. And what they do is they're removing, they're exchanging the radium for sodium. So if we go back to our periodic table of elements, these are divalent cations, these are monovalent cations, and so what happens inside of a water softener or inside of your drinking water supply, as we do with an ion exchange, is we substitute the divalent cations for the monovalent cations, and so we're doing an ion exchange, and so we're removing these things that also cause water hardness, which is our calcium and magnesium, cause our water to be hard. And we also remove radium at that same time. So it softens our water slightly, and it gives us better water, and then it removes the radioactivity too. The other thing, when people talk about this being just a problem of DeKalb, I'm like, no, it's a deep aquifer problem, and you can see where the problems are. And I'd like for you to look at this map and then look at what we've talked about with who's drinking groundwater in the Chicagoland area and in the state and where that is, and think of those maps together. And so is this a problem just of DeKalb, which is right there? So look at those things, make that decision for yourself. Okay.